Yes, class. Good evening. Am I audible to all of you?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Please open the camera, class. Everybody, please. Zaina, Rishita, Mariam, Khadija. Okay, let me start with the class. So in the last class, we were completing EM waves. On Thursday, we couldn't have the class. So let's see, let's have this class. And this week, you won't have any other class. So I think next week only we'll be able to arrange the classes, whether it's some extra through some extra classes or some exchange classes. Okay. So EM waves, we had started this portion, the generalized equation we had completed. What are EM waves? Also, we had seen these are accelerated charges. They are propagating perpendicular, and this table I have shared. So I hope all of you have received this. All of you have got this.
Yes, ma'am.
Okay, Zaina. Then please learn that table in the next class. Then I'll try to ask you the questions from that. Properties of EM waves also we have started. And all these properties, energy, density, momentum. Till momentum we have completed, intensity also. So only directly from the numericals we have to start. So this question says a plane EM wave of frequency 25 megahertz travels in free space along the x-axis. At a particular point in space and time, electric field is 6.3 J cap Newton per Coulomb. What is the magnetic field at that point? So when you are calculating the magnetic field at that point, a relation we had seen in the last class that, speed of light is 3 into 10 to the power 8 meter per second. Magnetic field you have to calculate. So see, speed of light is equal to electric field by magnetic field. So straight away magnetic field will be equal to electric field divided by the speed of light. So hence you can say magnetic field is 3.6, sorry, 6.3. This is 6.3 divided by 3 into 10 to the power 8. So this is 21. 2.1 into 10 to the power minus 8. And this is magnetic field, so it will be Tesla. Okay. One more question we will see. Please write this down. Rest of you, please. Siddiqa, Zaina, Mariam, Yahya, Khadija, open the cameras. Okay, not Zaina. I think Zaina has texted. Okay. Okay, class. So the magnetic. Yes, why other students are not following the instructions? Magnetic field in a plane is given. See, class, when you have this kind of equation, one equation we had studied initially in the first class of EM waves. So you write the main equation. This is saying B is equal to 2 into 10 to the power minus 7 sine 0.5 into 10 to the power x plus 1.5 into 10 to the power 11t. So you have to write the main equation. Main equation means the equation which we studied. B is equal to B naught sine k x plus omega t. Look here, this is the same equation. So now you have many things present in front of you. What is the wavelength and the frequency? Wavelength is directly not given, but we have studied that wavelength can be calculated through the angular wave number, right? So Mariam, out of all these, which one is used, can be used to calculate the wavelength? You can turn the page, see. First, check your first notes, first class notes. Can you see anywhere wavelength is being connected to any of these?
Actually, my book got over, so I have like the new book.
What happened? You have not written?
My book got over the last one, so I took a new book.
These notes one,
Yeah, the last class notes.
what happened to them?
The book got over, so I took a new book.
Okay, so you
I
don't
didn't
have
have
the
these.
notebook currently with you.
Yeah.
Anyways, firstly, you all should have revised this before the class. And secondly, when you are getting this liberty to check the notes, so keep these notes prior ready to the class, okay? Khadija, can you tell?
I have not written it.
Check. You must have written somewhere in the notes any of these which is written. Any of these which is related to lambda, wavelength. Wavelength is represented by this symbol. Anything. K. Class, it's K. Please start revising, class. This is not how you have to appear for the before the class. See, K is equal to 0.5 into 10 to the power 3. So K is equal to 2 pi by lambda. Okay, class, remember this relation, all of you, Mariam and Khadija especially. Remember this relation from now on. K is equal to 2 pi by lambda. If you have K, that is angular wave number, you can directly get wavelength lambda in your answer. Now we require lambda, so we will use 2 pi by K. So lambda is equal to 2, pi is 3.14, K is 0.5 into 10 to the power 3, this much meters. So this will be 4 something, 4, then 12, so 1.2 something, it will come. You can calculate that. Second says that wavelength and frequency. So frequency, we have been using it. Frequency we have been using quite often. Siddhika, can you tell for frequency out of all these which should be used? No. Okay, Taha, you answer.
Formula.
Yes, Taha?
Are you asking the formula?
You don't know.
What are you asking?
What happened, Taha? You were not listening.
No, ma'am, I am like, were you asking the formula?
No, I'm saying out of all these, how should I get frequency? Wavelength, I told you how to calculate. How will I get linear frequency? It's asked in the question. You all have not revised. What is the wavelength of ultraviolet rays? Should I then start asking these kinds of questions to all of you? I didn't even ask anything from the electromagnetic spectrum because that will take a little time. But at least you should revise all these things before the next class. The previous question also was very easy, but I didn't let you solve. I just did it myself because suddenly remembering that formula might be a little difficult. But this is everything is in front of you. K is equal to 2 pi by lambda, you all could not tell. And omega is equal to 2 pi nu. This we have done in resonance also recently. I'm not even talking about the questions before which we have completed. Omega is equal to 2 pi nu is a very, very common relation, class. When I was teaching that time also, I told you, do not forget this relation. 2 pi nu. Nu means the linear frequency is equal to omega, which is the angular frequency. So linear frequency is 2 omega by 2 pi. Remember we did the resonant part where we got Q factor. So in the resonant portion, we got omega is equal to 1 by root L. So using that relation, we calculated the frequency. So omega is equal to, in the question it's given, okay, it's equal to 1.5 into 10 to the power 11 by 2 into 3.14. So this much of hertz you can calculate for the first part. Second part of the question says, write an expression for electric field. Now, when you have to write an expression for electric field, magnetic field is given, you need B naught. See, class, please hear first, then you all can write it later. Because when you are asked, then you don't answer. So it's better you understand first, then you can remember directly also. See, when you are asked to write the equation of electric field from the equation of magnetic field, then what you have to do, straight away get the value of E naught. C is equal to E naught by B naught. Okay. what is E naught? We have to find it out because B naught is given. So what we'll do, we'll calculate the value of E naught as C into B naught. So this will be straight away 3 into 10 to the power 8, and B naught was given 2.5. 2 into 10 to the power minus 7. 2 into 10 to the power minus 7. So this is 60 Newton per coulomb. Okay. So this is C naught. Now when we are writing the complete equation Ey, everything will remain the same. What will be different is will be this value. E naught sine kx. K was 0.5 into 10 to the power 3 kx plus this was 1.5 into 10 to the power 11 t, right? This much of Newton per coulomb is this is how you have to write down the equation for electric field using magnetic field. Kx omega, see this was omega, this is k, this will remain the same, just that E naught you have to figure out. All right, write down this, then we'll start with Maxwell's displacement current. Displacement currents equation is important, and that will complete a major portion of this chapter, and we'll be able to complete it. Please write this. Okay, Maxwell displacement current. Let us start with the Maxwell's displacement current. So there was an experiment which was done by Maxwell, and there's a slight modification only. You all know about all these things and you have studied. So see there, these are two capacitor plates, okay, and they are connected to a battery. This battery produces current I. So there was a loop which was taken here. Let's say this loop is C1, circle C1. Okay. So in this C1 loop, it was observed that B dot dl, enclosed integral of B dot dl, was equal to mu naught I. Can anyone tell what was this law? What was the name of this law?
Biot-Savart's law.
No. Biot-Savart's law wasn't this. B dot dl is equal to mu naught I. Yeah, Mariam.
Ampere circuit.
Very good. Ampere circuit law. So according to Ampere circuit law, B dot dl is equal to mu naught I was fine. But then a loop was taken in between these two. That is C2 here, in between these two, where an interruption is present. Here current was flowing. So that's why this gave you this answer. But when we are talking about C2 loop, closed integral of B dot dl gave mu naught into 0, because there is no just this circular part. Because in capacitors, what happens? In capacitors, one plate induces the other plate. That's how the charges are transferred. But when you're taking a section, when you're taking a loop, in that loop, you won't get the amount of current. So that's why mu naught into 0, and straight away this is equal to 0. This is about C2 loop, and this is regarding C1 loop. So this is the difference. It means straight away closed integral of B dot dl came out to be 0, right? This was one thing. So this result of Maxwell is inconsistent with the Ampere circuit, right? It means both of them are not matching. So, but Ampere circuit law is a proper law, and we have studied its proof also. So why is it not applicable when we are talking about the electromagnetic waves? There is an inconsistency. Both of them are not consistent with each other. Okay, there is no parallelism between these two. So it means the current which we talk, see, every derivation is not there. Everything was done experimentally only. So what were the results of experiment? That is what we are studying. So the current, that is the mu naught I enclosed, this I which is enclosed, this I, in the Ampere circuit law, what do we use? Closed integral of V dot dl is equal to mu naught I enclosed. If you remember class, we did this enclosed part, right? So this exactly, this I enclosed is not just equal to the current which is flowing within the circuit. It has some additional current also, which is called the displacement current. Okay, there is this additional current also, which is called the displacement current. What is this? This is that mu naught I enclosed V, right? This is actually the I enclosed part. Okay. What is C? IC means the conduction current. The current which flows, the DC, normal current which we use. So this is the conducting current. And what is ID? ID is the additional current which is balancing. So this ID is the displacement current. This ID is the displacement current. Okay. Sufyan, please repeat so that it will give us a quick revision. Adjust your camera properly, Sufyan, first. And this is for all of you, not just Sufyan. Rishita also. Everybody, please adjust the camera properly. You're not just opening it for just following the rule. It is for an interaction. Sufyan, I said something. Please adjust the camera properly. I said that the current which is enclosed within our circuit, that is not enough because in case of EM waves, because it is not matching with the Ampere's consistency, Ampere circuit law. Okay, class. So this Maxwell law is not matching with it. It means some component is missing. That missing component is the displacement current. I is equal to IC was before this, whatever we have studied. That current is just the current present in the circuit. There is some additional current whose value ID, displacement current, is epsilon naught d phi over dt. This is the formula of it. ID is equal to epsilon naught d phi over dt. Okay, class, this is the formula of it. When we are talking about IC is present, this is the current in the circuit, which we have been studying. Okay, current in the circuit, and this is the displacement current. So what is the displacement current? It is that current that comes into existence in addition to the conduction current. In addition to the conduction current, whenever the electric field and flux change with time. This is an additional current. So I enclosed now, in case of EM waves, comprises of two currents, conduction current and displacement current. Is it clear, class, till here?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So see, now the formula I enclosed, this is your complete I enclosed now in case of EM waves. It is IC plus ID. So when you write the complete formula now, a closed integral of B dot DL, this is equal to mu naught. IC is the conduction current present in the circuit plus epsilon naught d phi over dt is the part of displacement current. This is the equation of the displacement current. Okay. Yes. Yaya, please brief us about the Gauss theorem. What was Gauss theorem?
Charge enclosed in a surface is times 1 by epsilon naught times total charge enclosed by the surface. Q is equal
Total charge enclosed by epsilon naught is equal to
no, charge enclosed by the surface is 1 by epsilon naught times the total charge enclosed by the surface.
charge enclosed is equal to 1 by epsilon naught times the total charge enclosed. Rishita, Gauss law.
Ma'am, that T type equals to Q by epsilon naught.
Q by epsilon naught is equal to
Um, it was the
what was Gauss theorem, class?
electric field and area. Electric EA equals to Q by epsilon 0.
So what is Q by epsilon naught and EA equal to? What was that quantity?
Phi?
What?
Phi?
What was phi? Name of phi was?
Um,
Electric flux.
Electric flux.
Electric flux. Yes, Taha, your answer was right. You people have forgotten Gauss theorem. I think we took a lot of time in the first chapter. First chapter, second chapter, we didn't rush up because these small chapters were there. We took so much time and you people are forgetting Gauss theorem. Gauss theorem, you shouldn't forget. Gauss theorem is one of the most important laws which you have in physics. Phi, the electric flux, is 1 by epsilon naught times the total charge which is enclosed. This is the Gauss theorem. That's it. Phi is equal to Q by epsilon naught. But you all couldn't remember it properly. Why just Q by epsilon naught? Yeah. What happened? Gauss theorem. So from here, d phi we can say is equal to dq by epsilon naught. Why dq? Because we are talking in terms of small charges, small flux. So this is from the Gauss theorem. Okay. Now B dot dl, when we are referring to B dot dl, this is equal to, you have the flux present. Okay, flux is equal to dq over. Yeah, Sufyan, you saying something? So dq over epsilon naught is your Gauss theorem. So when we are talking about B dot dl, this mu naught will come. IC is already there right now. I'm not mentioning it. Epsilon naught is there. I'm just solving the displacement current part. For d phi, I can write dq over epsilon naught by dt. This dt is present. It means epsilon naught will be cancelled. And what is dq over dt? Yes, Zaina, what is dq over dt?
Current.
Current. Good. So dq over dt is equal to the current. Right? So this is equal to the current. It means for the displacement current part, we can directly say B dot dl is equal to mu naught I. Now see, is it consistent? This was our Ampere's law. Now see, using the displacement current only, I have derived this, right? Now we can say only this part was missing in EM waves. That's why we couldn't. So this shows consistency in the Ampere circuital law. Okay. Write it down from here. Okay, let us quickly complete. Only some portion is left. See, some properties of the displacement current. Whenever a change in flux will be there, displacement current will be produced. It's like whenever the flux increased or decreased in Faraday's laws also, we said that current was induced. So similarly here also, whenever there's a change in flux, it will only produce the displacement current, because we've seen how it is directly proportional to it. Displacement current produces magnetic field, right? Displacement current produces magnetic field. Displacement current is directly proportional to the magnitude of charge. We have seen when we were writing the deriving it, we ultimately equated it to dq over dt to I. So that's why it is, and charge in any way is directly proportional to current. So magnitude of displacement current is equal to the rate of displacement of charge from one capacitor plate to another. Here, the difference is that these two capacitor plates are present, and when the charges are getting induced, because with the by the process of induction only, the charges are traveled from one plate of the capacitor to another. So this is equal to the current, because ultimately this is only the rate of flow of charges will determine the current. It satisfies the property of continuity. Means displacement current has no breakage, it is continuous. Please write down the properties also. Okay, class, let us discuss this question. So it says that a parallel plate capacitor has circular plates, each of radius 5 centimeters. It is being charged so that the electric field in the gap between the plates rises steadily at a rate of, see, when this is given, electric field rises at a rate of, means that whenever the term rate is mentioned, I have told you, this is always with respect to time. So rate of change of electric field means electric field per unit time. See, this volt per meter is already a unit of electric field. Per second, this is a unit of time. So basically dE over dt is equal to 10 to the power 12. This is what? This is the rate of change of electric field. Rate of change of electric field, dE over dt. Radius is given? Yeah, radius is given. So radius is 5 into 10 to the power minus 2 meters. Okay. Now, what is the displacement current? ID we have to find out. So epsilon naught d phi over dt. Epsilon naught we know, dt we can figure out, but what about phi? For d phi, we will calculate it through the flux. Flux is equal to electric field into area. Yes, class, electric field into area can be calculated, right? So electric field, this is equal to, let's leave this. Let's leave the electric field as it is. Okay. Let's do one thing in the equation of displacement current, which is epsilon naught d phi over dt. Let's put this value. So displacement current will be epsilon naught d e into a over dt. Current area is constant, so epsilon naught a will come out and you will be left with dE over dt. Class C, dE over dt is as it is given. Right? dE over dt is given in the question. Epsilon naught, you know, area you can calculate for a circle. It is pi r square. Yes. So ID will be equal to, yes, what is the value of epsilon naught, Sufyan?
8.85 into 10 raised to 12.
How much, Sufyan? What is the value?
8.85 into 10 raised to 12.
10 to the power?
12.
10 to the power 12. Eight 8.85 into 10 to the power 12. Can anyone correct him who thinks he is saying it incorrectly?
Minus 12.
Minus 12.
Minus 12. 8.85 into 10 to the power minus 12 into pi. Radius square 5 into 10 to the power minus 2 whole square, pi r square into, this is 10 to the power 12 given. So when you will solve, this will be 6.94 into 10 to the power minus 2 amperes. Around 0.07 amperes, the answer will come. Please write this question, the solution for this question. I hope everybody has written the question. If anyone wants to see it, please tell me. Text me done class if you will complete it till here. Okay, Rishita and Siddhika, you both stay. Rest of you can leave. Class this completes with a full chapter of EM waves. The electromagnetic spectrum, you have to do it on your own. I think, see, this week you don't have any other class for physics. Thursday is an off from my side. If your other class is substituted, that you can check from the team. But my class is not there on Thursday. Maybe we can have a class on Monday or some other day when you all are available. In compensation for the previous Thursday's class and the coming Thursdays. Two classes are, one was missed last time. The other